We're here today with Hugh Van Horn, author of Inside the Stars. Mr. Van Horn was a member of the University of Rochester's Department of Physics and Astronomy for nearly 3 decades, becoming Professor Emeritus of Physics and Astronomy in 2005. He joined the National Science Foundation in Washington, D.C. in 1993, where he served as a director of the Division of Astronomical Sciences and later as director of National Facilities for the Division of Materials Research. After retiring, he has devoted his time to working as an author and as a freelance editor. His previous astronomy book, Unlocking the Secrets of White Dwarf Stars, was published by Springer in 2015. Mr. Van Horn, what inspired you to write Inside the Stars?
Well, today we astronomers speak very knowledgeably about what goes on inside the stars. But how do we know? We can't bring a star into the lab and make measurements. So I figured that there would be people who are interested in astronomy, but who are non-scientists who might be interested in this. And I figured that an historical narrative would be the best way to explain it. And since I've spent most of my career working on studies of the properties of matter inside the stars, I thought I'd be a good person to do this.
Thank you so much for your answer. How did you balance the technical aspects of astrophysics with making the book accessible to the general audience?
Well, after I wrote the first draft of my previous book, I showed it to my wife. She was a registered nurse, and so she's a typical example of the kind of intelligent non-scientist that I wanted to have as the target audience for my book. She looked at it and she said, "Take out all the equations." So I did what she said, and that helped. But in addition to that, I've spent 10 years or more editing documents to try to make them clearer to people. So I think all of those helped.
Thank you so much. And I was going to ask you, what are the key topics covered in the book?
Well, I started with the historical development of our understanding of how the structure of the sun, how we came to understand the structure of the sun. And then I move on to discuss more modern research on the solar interior, for example, using solar neutrino physics or helioseismology. Once we understand the inside of the sun, which is a star that burns hydrogen, then we can understand other types of stars that also burn hydrogen. But when a star runs out of its hydrogen fuel, it has to change. We astronomers call that stellar evolution. And what happens then? And when stars run out of all of their nuclear burning fuel, or they die, as astronomers say, how does that happen? So I discuss these things in the book as well. Then there are some stars with special characteristics that I couldn't figure out. Cataclysmic variable stars that show eruptions of various kinds. And in particular, what I found very interesting was the very first stars.
In your book, you also highlight the role that women have played in the development of our understanding of stars. Could you please speak about the importance of inclusivity in astrophysics?
Sure. I think that science, I would like to think that science evaluates the contributions of people based on the merits of their ideas rather than on their gender or skin color or ethnicity or whatever. I've also been privileged to work with some outstanding women astronomers, in particular my colleague Judy Pfeiffer at Rochester, the late Judy Pfeiffer, and the late Vera Rubin at the Department of Terrestrial Magnetism. And I've been very impressed with in both cases, their focus on the science rather than on gratifying their own egos. In general, I think it's important to accept the contributions of individuals regardless of where they come from, as long as they're from smart, knowledgeable people.
Thank you so much. And I was going to ask you, how did you decide on the structure and organization of the book?
Well, I think it's interesting that this actually changed as I was writing the book. Originally, I thought I would do just a straight historical narrative, starting in 1800, whenever, and going on and on. But then I got to the point of discussing the modern solar neutrino research and realized that solar neutrino investigations, helioseismology, and the nature of stellar evolution were all being understood at about exactly the same time. So if I had stick with the historical narrative, I'd be jumping back and forth between these different topics. I thought that would be confusing. So instead, I decided to put them all together at the end of the book after I describe what happens with normal stars to provide background.
And you have touched on this already, but are there any particular discoveries or insights you made during the writing process that maybe like surprised you or made you change the structure?
Yes, actually, there were.
Yeah.
The first thing that surprised me was that I did not realize that it was a woman, Cecilia Payne, who was actually the first person to realize that the sun and other stars are made primarily of hydrogen. Before that, astronomers thought that it was mostly heavy elements inside the stars. The second thing was that, although this is not original with me, in the Big Bang did not create very many heavy elements, nothing heavier than atomic weight about 7. And so the stars that were formed, the first stars that were formed after the Big Bang, could not have had heavy elements and therefore would have had properties and would have evolved differently than stars today. So those were two things that surprised me that I discovered as I was writing it.
Thank you so much. In your book, you also mentioned that we are only beginning to learn how the first stars were formed. And I was just wondering if it's a topic that you might be interested in exploring further in the future.
Well, I do expect that investigations of the properties of the first stars are going to become increasingly important in the future, and I'm going to be very interested to find out how that goes. However, I think that other people will be in much better position to discuss that than I will.
Can you please also tell us about your current research project and have your interest shifted since writing Inside the Stars?
Well, I've not actually been involved in active research for about 2 decades now, so I'm not
Mhm.
current on that. Um, so in addition to this book on stellar astrophysics, as you mentioned earlier, I've also written a book about the white dwarf stars. In addition to that, I've written a couple of small books about historical aspects of a centuries old church in Alexandria, Virginia, where my wife and I used to live. And I'm currently working on a couple of memoirs centered on a small lake in western New York State where we used to own a cottage.
What do you see the most exciting areas of research in astrophysics today?
Well, I've already mentioned research on the first stars, and I do think that's going to be increasingly important. I also think that studies of the early universe, the nature of dark matter, extrasolar planetary systems, and things like that will be among the most exciting areas of astrophysical research. In addition, the Vera C. Rubin Observatory is currently being constructed in Chile, and I think that that's going to make possible an entirely different kind of uh, of results than we've had to now. And so I think there will be areas of investigation that will open up that we can't even foresee right now. In addition to that, I think laboratory astrophysics is extremely important. In particular, in the past few years, scientists working in the labs have been able to make plasmas that uh, are like, sorry, scientists working in these areas are beginning to be able to make plasmas that are mimicking conditions like those inside the stars. So we can begin to make actual measurements that will help us to understand those properties better than the theories that have been used to this point. That's not to diminish the importance of theory. I think theories are vital, but it's also important to test them every time.
Thank you so much. And your book encourages people to pursue a career in STEM. And I was just wondering if there's any advice you can give to early career researchers on just in general people who want to pursue a career in STEM.
Well, I do think that the world is increasingly going to need smart people involved in the STEM areas. Smart people generally, but also smart people involved in the STEM areas. And it's commonly known in science that it's the smart young people that tend to make the path-breaking discoveries that lead to the future. My best advice, I think, to a young person considering a career in STEM is to find something that truly interests her or him and work hard at it. That would be my best advice.